actually. Okay, everyone say hi to your class teachers, awesome class teachers. Yellow bhai. For all the people, for whomsoever it may concern. To whomsoever it may concern. Okay. कभी कभी तो छुट्टी मिलती है टीचर्स को. Let them enjoy some time together. Okay. Absolutely. तुम्हें भी कुछ दिनों की छुट्टी मिली है. Enjoy that. Okay, guys. अरे Shimon sir is not going to get married. Shimon sir has gone to attend the wedding. अभी basic English भी मैं समझाऊं. Okay. Did you guys say hello to your class teachers? Gautam sir, Shubham sir, Rishabh sir, quickly say hello to your class teachers so that we launch quickly from here. Great. Okay. So everyone, switching off the chat as always so that we can start. Today, the very good news is we have only 3 slides of theory. We have only 3 limited slides of theory today. No theory, only problem solving. That's how we like it, right? We like physics for that reason, especially 11th standard physics. I love 11th standard physics for that reason only. Limited theory, unlimited problem solving. Okay, so let's go. Let's move on quickly. And now switching off the chat in 5, 4, 3, 2, 1. Stop writing, please. And here we go. Okay, so everybody, this is what we learned in the previous session. Momentum and collision is the name of the chapter. And broadly, if I have to recap what we learned in the previous session, there was only one big thing that we learned, and that big thing is actually a huge thing because that's the third law which we needed to see in order to understand mechanics completely. So we already are aware about the laws of motion, we are aware about law of conservation of energy, and now we know something called as law of conservation of momentum. Okay, so what we understood there that if there is a system which may have multiple bodies involved, and in that system, 3 possibilities or 3 scenarios that you will be dealing with. One scenario, if there is an object which is breaking down into multiple objects. Second, one object is going to collide with another object. That means first is collision, second is explosion. Okay, I said explosion first, but first is collision, second is explosion, and third, when there is an object moving and you gently place another object on it without applying any external force. So as long as there is no external force applied on a system, choice of system is very important. So you can say that if there is no force applied from outside, then center of mass is not going to experience any force. If center of mass does not experience any force, if this situation holds true, then the velocity of center of mass will be constant. We can actually say that its momentum is also going to be constant, and we can say its acceleration is going to be 0. Remember, momentum is constant. Momentum is not 0. Momentum and velocity remain constant. 0 is also a constant. So if center of mass is initially at rest and say it explodes, the body explodes. The body, whenever it will explode, the parts that it will break down into, they will move opposite to each other. That's the part that you need to always understand properly. Okay, so this is something that we did like a lot of discussion on this, and after the class also I took a lot of doubts on the similar thing. So if you guys understood the topic properly, then you would definitely enjoy today's session as well. And based upon what we learned last time, a question for you guys to try. A bullet of 10 gram is shot from a gun of mass 5 kg. So bullet mass is 10 grams. The mass of the gun is 5 kgs. 5 kg gun is separate mass. 10 gram bullet is a separate mass. So total mass of bullet plus gun is 5 gram plus 10 grams. Okay, so 5 kilograms plus 10 grams. So in this case, they say that after the bullet has been fired, the velocity of the bullet is 1000 meters per second. So what do you think will be the recoil speed of the gun? What is the recoil speed? Once you fire a bullet, the person who's holding the gun or the gun itself comes back, you can say, or you can consider it to be like a cannon, the example that we saw last time. Okay guys, so giving you guys 16 seconds and your time starts in 3, 2, and here we go. Come on everybody, quickly solve it. Come on, we need to maintain a good speed today. Everybody, we are targeting to finish today by 9:30 the slides so that I can still give you guys some time after the class. I don't want to finish at 10 and then not talk to you people. Okay. Last 10 seconds now. Okay. And time's up. So it's a very easy question, everybody. We know that initially the gun along with the bullet is stationary, right? So initially the bullet is here, and capital M mass and small m mass, they both have 0 velocity. After that, what happens? Your bullet starts to move with a velocity v1, then definitely your gun will be recoiling with a velocity v2 having a mass capital M. So if we speak about the initial momentum, it should be equal to the final momentum, and in this case the value is 0. Yes, because initially the momentum was 0. So final momentum is basically m into v1 plus capital M into v2 equal to 0. So this way, when I calculate the value of v2, this is mv2, which is equal to minus mv1. So this minus sign is indicating the recoiling of the gun. Minus sign is indicating the negative direction of the momentum of the gun. So v2 will be minus small m by capital M into v1. So small m is 10 grams. So 10 into 10 to the power minus 3 upon mass of the gun, that is capital 5 kg, and velocity is 10 to the power 3 meters per second for the bullet. This gets cancelled. 10 by 5, v2 comes out to be minus 2 meters per second. This minus sign is indicating that your gun is moving opposite to the direction of bullet. Okay guys, cool, awesome. So the only topic that we will be studying today, not because I have a meeting, it is how it was planned. Okay, so the topic that we'll be covering today is called impulse. We very briefly talked about impulse in the chapter of laws of motion, and actually the understanding remains the same, but today you're going to see a lot of problem solving based upon the same topic, impulse. Okay, so let's first understand what exactly impulse is once again. So this iconic shot everyone remembers, 2011, right everyone? This is Wankhede Stadium in Mumbai, but this is not where I want your attention on. This is basically the event that you have to look at. Many times when the force is acting for a very short duration of time, the effect is actually instantaneous. So within an instant, the direction in which the ball was going is changed. Okay, this is possible when the force is acting for a very short duration of time and it is delivering an impulse. Okay, when we speak about the impulse mathematically, we all remember that impulse is defined as the force acting for a very short duration of time or for over a given period of time. Not just short duration of time, generally the interval of time for which it is acting. So mathematically, when we try to write impulse, which is absolutely a vector quantity, is nothing but the force and its product with the time for which the force is acting on the body. And I gave you guys a lot of examples on the fact that how the force is going to create its strength when it is trying to change the momentum, right, everyone? So remember one very important thing in the beginning part of this discussion itself, that when we think of impulse, we actually try to think of something trying to do a bam, right? So this sudden impact that we speak about, in this, we always misunderstand the force with impulse. Means what? When we talk about, I'll give you the same example which I gave you guys earlier when I was talking about the laws of motion. I gave you guys an example and I proved it to you that when we speak about force, which is defined as the rate of change of momentum, I gave you guys an example that say there is a car which is going, passengers are sitting, and the car is going with a speed of 80 km/h, and suddenly somebody comes in front and the driver has to apply the brake. In that case, the people who are sitting inside, they actually experience a sudden and a very large force. Means you will say it is dangerous because the impact is dangerous, or rather it is very impactful, the situation. On the same situation, when we speak about a car going at 80 km/h, you see that there is a signal getting red, you take 5-6 seconds, apply the brake, stop the car. In both the cases, the momentum is going to change by the same amount. Same mass of the car, same initial velocity 80 km/h, same mass of the car, and same final velocity in both the cases, that is 0. So change in momentum in both the cases when the car is stopping suddenly or the car has been brought gradually to the rest is same. But it is delta t, the time for which the force is acting, that creates the difference in the magnitude of the force, right? So basically, how fast you are trying to change the momentum defines the force, and that is where force becomes impulsive or non-impulsive. If an effect is generated by a force within fraction of seconds, within very small interval of time, you will say that the change in momentum is sudden. Means what? You talk about the change in momentum being equal to f delta t. Are you realizing the similarity between impulse and change in momentum? So guys, remember, impulse technically is different quantity, but practically it is same as that of change in momentum. Means it will have the same units, it will have the same dimensions, and mathematically you will actually be calculating the same thing only. But the understanding of it has to be clear. Impulse is basically trying to make us understand whether the effect which is generated by the force is sudden or it is not sudden. So if the force is trying to suddenly change the momentum of a body, again taking you to this video to see that the direction and the speed or velocity of the ball is suddenly changed just by the hit from MS Dhoni. That sudden contact with the bat changes the momentum of the ball, and because of that, the force that has to act on the ball is actually very, very large in comparison to usually when you try to throw a ball. Okay, guys. So that is why the force in the situation when the momentum is changed suddenly will be called impulsive. Remember, it is force which is called impulsive or non-impulsive. But as long as the momentum is changed by the same amount, as long as the change in momentum is same, there could be two situations where the value of impulse be same. We will solve a few questions today where you will see this and you'll understand it much better. But for now, let's see if you are able to have this takeaway with you or not. Okay, people. So basic things are clear. What is impulse? It's same definition. Force acting for a duration of time. You will call a force being impulsive if it is creating a change in momentum, if it is acting for a very short duration of time. Okay, people. So how will you calculate the impulse value? Simply, if force is constant, you will directly calculate force into time. If the force is variable, you will require the force to be as a function of time, so that you can put this here and integrate. You will integrate it from t1 to t2. You can write force as mass into acceleration if required. Okay, and acceleration can be written as dv by dt. So you can also write it as integral of mdv, which is also trying to tell you that it is nothing but change in momentum. It's the same thing which we wrote in the previous slide. So remember, this is a very important confusion for us mathematically. Okay, guys, you will integrate for calculating the impulse only when the force is variable. Remember that. Okay, so can I say that if impulse is the result of integration of force and time, then if I get to draw a graph between force and time, then definitely the area of that graph will give me the change in momentum or impulse. Both are the same thing. Important part, area above x-axis is called positive, area below x-axis is called negative. Okay, everyone? Plus one if you guys understand everything so far. Actually, nothing new has been learned. It is only what is going to follow will be different. That's the problem solving part of it. Okay. Formality, it is a vector quantity. Dimension same as that of momentum, m1 l1 t minus 1. Units also same as momentum, kg meter per second, and its direction is along the change in momentum. Okay. Cool, everyone. Theory done for the day. Theory done for the day. Okay. Only problem solving. Everybody ready for problem solving? Don't worry, session nahi end ho raha hai. Session is still there. Many problems to be solved today. Shall we go? Everybody ready? What will be the slope of FT graph? Whatever it will be, it will not be a physical quantity. Amal, Jenna, the slope of that graph will not be a physical quantity. Okay? Please wait a little. Kyun? ये impulsively खत्म भी हो गया actually. Sir, why indefinite integration? No, depending upon limits, we can actually call it definite or indefinite. Okay? Okay, guys? Derivation of integration part है. कौन सा डेरिवेशन भाई? क्या क्या इमेजिन करने लगे तुम लोग अभी से? कौन सा डेरिवेशन? मतलब जहाँ लाइफ ऑलरेडी इजी है तुम उसे डिफिकल्ट बनाना चाहते हो? Is that what it is? हाँ? अरे मनन, what do you think I'm running a news channel at Vedantu? What do you guys think? Am I running a news channel that I keep the report of every single teacher on Vedantu? That you keep on asking me, sir, when is Harsh sir coming back? Why Shimon sir is not taking the lectures? Huh? Stop asking all these questions to me. I'm a very reserved person. I do not interfere with other people and their lives. Okay? Yeah. Chale, everyone. Chalo guys, let's start the problem solving. Switching off the chat. Please stop writing in 3, 2, and 1. Look at the example, everybody. It says that a hammer of mass 1 kg moving with a speed of 6 meters per second strikes a ball and comes to rest in 0.1 second. You have to calculate the impulse of this force. Okay, so I don't want to solve this question myself. I want you people to do this for me, setting up the quiz and be ready to solve this quickly, everyone. What's the other time they do? I'll not give much time for this. It's a very simple one, giving you 45 seconds. Time starts in 3, 2, and 1. Come on, everyone, quickly. I've written everything on the screen. Nothing more can be spoken about this question. You are the only one who's taking the lectures. That's why. मैं अकेला lecture लिया तो सारे सवाल मुझसे पूछोगे. Non-academic भी. छुट्टी मिली है. If your lectures are not happening for other teachers, enjoy that time. Study more physics, solve more questions. Okay, keep calm and solve physics. That's what you do. हमें अगर हमारे टाइम पे छुट्टी मिल जाती तो we used to be so happy. Okay, teacher is not there. That's really good. Let's go home. Oh, but you guys are already at home. Chalo, that's good. Let's see how you guys did. That's a very simple, easily doable question. All I needed was to find the change in momentum. If I'm talking about a hammer which is already moving with 6 meters per second, if a hammer is going to do this hammering, so whenever the hammer is going to hit a surface, on hitting it has to stop. So its initial velocity is given, final velocity has to be 0. It will not be given. So initial velocity is 6 meters per second, final velocity is 0. Change in momentum will be mass into final velocity minus initial velocity. This is the most important part where plus or minus will be taken care of. Okay. So mass of the hammer is 1 kg, final velocity is 0, initial velocity is 6 meters per second. So that's why the change in momentum is minus 6 Newton second. Okay, everyone? That's why the correct answer to the question is option B, minus 6. Okay. Now the next one is more of a conceptual question. Be very careful when you are reading the question and carefully analyze it. There is nothing to be solved, but has to be understood. Question in front of you. In the first time when I saw this image, I felt like it's basically, a photograph made of a person, but it is actually a plate which is broken. Yeah, so it's a broken plate. When a dish falls, in which condition the impulse will be less? When it lands on the carpet, that is situation number 1, or when it lands on a hard ceramic tile floor. So where do you think the impulse will be less? When it lands on a carpet, relatively a cushioned surface, or when it lands on a very hard ceramic surface? Imagine in both the situation it breaks down similarly. Okay, so giving you guys 30 seconds and the time starts in 3, 2, and 1. Where do you think the impulse will be less? This is where the check of concepts will be. How much you have understood what I've said so far. Okay. I said this like at least 5 times when I was explaining the slide of impulse. What is impulse? It is force into the time for which the force is acting, and it is equal to the change in momentum. So guys, can I say that when you drop the plate, when you drop the dish, its initial velocity is 0. When it is about to hit the ground, say it has achieved 20 meters per second. And finally, when it stops after breaking, its final velocity will be 0. Guys, can I say that in both the cases, the change in momentum is same? In both the cases, change in momentum is same, impulse is same. Where do you think the force is impulsive, situation A or situation B? Force in which of them is impulsive? Obviously, when the plate hits the floor, the ceramic floor. That is where the force becomes impulsive. I told you, it is force which is impulsive. Okay, guys? Delta T definitely will not be same for both here. That is the whole point now. Why do you think when you buy or when you guys will definitely have crockery in your house which is placed in thermocol? Whenever the crockery comes, it comes in thermocol, or it is given paper ka cushioning. Why? So that the impact time is increased. More be the impact time, less be the force acting on the body. That's why. Okay? Is that clear? In the previous question we did not use the time, क्योंकि हमें understanding clear होगी तो हमें समझ में आएगा कि कौन सी information use करनी है, कौन सी नहीं करनी है. Manan Chaudhary, the force was not given to you in the question. That's why. Okay? If force would have been given, then I would have calculated the force multiplied by the time. Absolutely. Yes, the answer is C. Same for both. Okay, guys, is that clear? Chalo, switching off the chart so that you guys focus once again. Impulse doesn't depend on other objects, right? Impulse, velocity of an object is velocity of that object. Okay. Similarly, impulse on an object is the impulse of that object. It does not depend upon any other object. It's a very vague thing to say. Depending is a very broad thing to actually bring. If two players are playing football and they are both running towards the ball, and one of the player hits the other player and he falls, then definitely the other object has impacted the impulse of the other person. So it is very situation based what you are asking. Impulse doesn't depend on other objects. It's actually a very vague thing to ask, but situation to situation you'll be able to understand that you have to only focus upon that object. Free body diagram that you learned in the chapter of laws of motion. Okay, chalo people, let's solve more questions to understand better. This question says, it's an example, a cricket ball of mass 150 grams is moving with a velocity of 12 meters per second, exactly what Dhoni did. The ball was moving towards him at 12 meters per second and he hits with a bat and the ball gets turned back by a velocity of 20 meters per second. I've drawn the diagram. Okay, if the duration of the contact between the ball and the bat is given, find the impulse and the average force. First of all, Manan Chaudhary, time is given, but for that you will not be able to find out by using it the value of impulse. Why? Because the force is not calculated here. Force is not given in the question. So how will I calculate the impulse acting on the ball? The impulse will be calculated by change in momentum of the ball. Okay, and how will I calculate force? By calculating the value of change in momentum by the amount of time taken to change the momentum, or I can say impulse divided by change in time. That's how I will use the time given in the question. Now, before I even do any of these maths, look at the diagram very carefully, everybody. Say I define this direction to be positive and this direction to be negative. Directions are now very important because we are dealing with vectors. All of these are vector quantities. So when I calculate the impulse that's going to be change in momentum, I will say it is final momentum minus initial momentum. So mass into final velocity minus initial velocity. Let me ask you people only in the chat box. The mass of the ball is 150 by 1000. Agreed. How will you write final velocity? 20 or minus 20? 20 or minus 20? देख के बताओ. Is 20 meter per second the final velocity? It is. Is it in the right positive direction or negative direction? So it is positive 20. Thank you. How about now I'll have to write a minus sign. Okay. What was the initial velocity? 12. And what is the direction of that velocity? The direction is already negative. So you'll have to write minus 12. Are you guys getting this? Everybody. Are you guys getting it? There are two vectors which are in the opposite direction basically. So first vector is 20. The second vector is minus 12. Clear? So these two will effectively be added together. So everyone, it is 1.5. 1.5. 0.15. It is 0.15. 0, 0. 0.15 0.15 into 32. That's basically your impulse. And when you simplify this, it will come out to be 4.8 Newton second. You can do the maths. Calculations तुम कर सकते हो, obviously. And this is not just impulse. This is also the change in momentum. How will I calculate the force? Okay. How will I calculate the force? I'll just divide this by the time. Okay, people. So we got the value of impulse. Divide this by time. Time was given to us as 0.01. It will come out to be 480 Newton. Okay. Okay. Yes, Archana. If Dhoni would have been holding a cushion bat, then the ball will not go beyond the boundary. He'll be caught in that case. Okay. Yes, Shreyansh, we can do that also. We can do that also. It is not necessary that you have to consider this as positive and this as negative. But if you consider 20 to be in negative direction, then 12 has to be in positive direction. That's the thing that you need to understand. Okay? Yeah. Sure, guys. Yes, sign convention has to be maintained. So we got the answer. Next, another example. It says that a batsman hits back a ball straight in the direction of the bowler without changing. इससे मुझे याद आया India के साथ बहुत बुरा हुआ है. Today India has actually played with overconfidence, and I got to know that all out India all out for 78 runs. Utterly disappointed, but because we are solving a question which is related to cricket, that's why a batsman hits back a ball straight in the direction of the bowler without changing its initial speed. That means what? The ball was going, say, in this direction, that is 12 meters per second, and after being hit by the bat, it comes back with the same speed, 12 meters per second. Okay, so if the mass of the ball is given to you, determine the impulse imparted to the ball. Similar question, only impulse has to be found, and I will give you guys this question as a quiz. So all of you, be ready for solving this. Okay, giving you people 60 seconds. Time starts in 3, 2, and 1. Any of the velocities you can take positive, the other one will become negative. So you have to find change in velocity or change in momentum. Okay, and let's see how many people got this right. Well done, very good, very nice, very well done, guys, very well done. The correct answer to the question is 3.6 Newton second. So if I take the initial velocity to be 12 meters per second and take final velocity to be minus 12 meters per second, this time I'm doing just opposite. I'm taking final velocity negative. So finally the vector will look negative, but question has given us options which are only magnitude. All the options are positive. That means only magnitude has been talked about. So impulse is change in momentum, which is mass into change in velocity. So guys, mass of the body is 0.15, same as the previous case. Final velocity minus 12. Okay, and initial velocity is 12. So final velocity minus initial velocity. That's what it is. So you can see that it is 0.15 into minus 24. So when we do this, simplify this thing, this will come out to be minus 3.6 Newton second. This minus sign indicates the direction of change in momentum. And by the way, direction of change in momentum is the direction in which force is acting. Means what? Let me show it to you. If this is the bat and the ball was moving towards the right, guys, if the ball was moving towards the right and after hitting with the bat, it moves to the left. In which direction the force must have been applied by the bat? Left or right on the ball? Left में लगाया होगा force, right everyone? So this is the direction. So we have considered in the given solving, we have taken this direction to be positive and this direction to be negative. And what is the direction that we are getting as our force direction? Everybody, all of you are able to see that the force is actually pointing towards the negative direction. That is why the final answer is coming out to be negative. If we do the same thing here, just look at this case now. If we had a bat here, look at this. If the ball is moving towards the left side, where do you think the force will be acting after the impact is done? Where do you think the force will be applied by the bat? Can I say the force will be applied in the right side so that the ball eventually goes to the right side, right? So look at the direction of the force, positive. Force direction positive. That's why my final answer also was positive. Is that clear now? The direction of impulse is actually the direction of force. Okay? Are we clear with this? That's why when we look at the vector sign also, impulse and force are in the same direction. Good, more questions. So we did this, switching off the chart. Let's go to the next question. This is an example. It says that we have been given a situation where a hero of a stunt movie fires 50-gram bullets from a machine gun. Each bullet comes out at a speed of 1 kilometer per second. Very, very, very high velocity. Usually bullets come out with a very high velocity. So 1 kilometer per second is the speed with which the bullet comes out. The point is, the initial velocity of the bullet is 0. The final velocity of the bullet is 1000 meters per second. That's what 1 kilometer per second means. If he fires 20 bullets in 4 seconds, then what is the average force does he exert against the machine gun during this period? Or basically, how much force is applied by the machine gun on the bullets? That's how we can look at it. Or just to make you people visualize this part, your gun is actually firing how many bullets per second? 20 bullets in 4 seconds means 5 bullets per second. So 1, 2, 3, 4, 5 bullets are basically being hit in this direction by the gun. Right, everyone? So definitely all of these bullets when coming out, they are applying the same total force F. Okay? So each bullet is experiencing F by 5 force and overall force in 1 second. In 1 second, how many bullets are being fired? 5 bullets. So when you are calculating the force, you will have to calculate the force for 5 bullets and their change in momentum per unit time. Are you guys getting this point? When we calculate only delta P by delta T, we get the force acting on 1 bullet. Only on 1 bullet. But how many bullets are coming out in 1 second? How many bullets are coming out in 1 second? 5. So basically, when you are defining the force, you define it for 1 second. You are defining the force as change in momentum upon change in time. Change in time is taken as 1 second. So in 1 second, how much momentum is changed? So for 1 bullet, the momentum is changed in less than 1 second. So you have to take how many bullets? 5 bullets. Okay, guys, 5 bullets in 1 second are actually feeling that force together. Okay, ये समझ में आया? All of you got that there are 5 bullets coming out per second? Okay, everybody. So 5 bullets, the change in momentum will be m delta v by delta t. So let's solve it on the next slide and we see it. Okay, the value I'm going to solve it for you people. 5 into mass of each bullet is 50 grams. So 10 to the power minus 3 you will have to write. The initial velocity is 0, final velocity 1000 meter per second. So you will have to write 1000 minus 0. It is not a quiz. It is definitely a normal question divided by 1 second. Okay. If you would be taking 4 seconds, in denominator, how many bullets you will be writing? 20. But overall 20 by 4 will any which way be 5. 20 by 4 will be any which way 5. Getting my point? So I directly 5 will area. I've taken 5 directly for that. So 250 into 10 to the power minus 3 into 10 to the power 3. So how much force is applied in 1 second? 250 Newton. Remember, wherever time is involved in the formula of a quantity, we usually take the time, or we define that quantity for 1 second. Okay, like when we define velocity, we say it is change in displacement upon change in time, right? So we say that an object is moving with, in this question only, 1000 meters per second. It is defined for every second. It is defined for every second how much distance is covered. Like that, force is change in momentum in every 1 second. That's why. Understood? Sabko samajh mein aa gaya? Good. Very nice. Abhi, now I want absolute silence in the chat box. I want absolute silence in the chat box, because the next question is a very, 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 okay, very, very crucial question for all of us. Okay, there is something to learn in this question. So look at the question, guys. It says that we have a ball of mass 1 kg, which is, the ball comes, hits the floor, and when it is hitting the floor with the horizontal, it is making an angle of 53 degrees. After impact, it rises up, but this time the angle which it rises to is only 37 degrees. Okay. So question is asking us, what will be the impulse exerted on the floor? See, remember, impulse exerted on the floor means force acting per unit time on the floor. Force acting for that short duration time on the floor. Can I say, first of all, the force which is applied by the ball on the floor will be equal to the floor ka force applied on the ball? Can we say that? The force which will be applied by the ball on the floor and the force which is applied by the floor on the ball are action-reaction pair. They are action-reaction pair, right, everyone? So just one more thing that I want you people to tell me. If the ball hits the floor here, in which direction do you think that the floor will be applying a force on the ball? What will be the direction of application of the force? Can I say the force can be applied only perpendicular to the surface? Do we agree on this? This is the direction in which the force will be applied. Okay, this is the force applied by the floor on the ball. Okay, and this is also going to be the direction opposite to it, the force applied by the ball on the floor. Okay, are we clear? By looking at the direction only, the upward force is on the ball, the downward force is on the floor. That is why your ball changes the direction, by the way. You see that? Okay. Manan Chaudhary, do you happen to have? Yeah, you happen to have. Yes, Manan. Yes, tell me your doubt. Because the surface is horizontal, it can only apply a force vertically. Then also it will apply a force that is vertical, perpendicular to the surface. If the surface becomes this, then the force also becomes perpendicular to it. In any surface, perpendicular to the surface. Perpendicular to the surface. Now your surface becomes vertical, the force becomes horizontal. Getting? Yes. And guys, as the surface is smooth, there is no force of friction. There is no horizontal force. Okay, everyone? Mg is there, definitely Mg is there. But is Mg being applied by the floor? When a ball will hit this, when the ball will hit this surface, will Mg be applied by the surface on the ball? Who's applying Mg on the ball? As a quick recap, who's applying Mg on the ball? Who's applying Mg on the ball? Thank God you remember. Earth is responsible for Mg. Thank you. So the force because of which the ball is changing the direction is not because of Mg. The ball is going to change the direction because of the force applied by the floor. Am I clear? Do you see ball direction is changing? Visibly, can you see that? Right, everyone? Okay, now just one more thing, everyone. If the direction of the force is vertical and no force acting in the horizontal direction, do you see that, everyone? The force acting in the horizontal direction is 0. So can I say that acceleration in the horizontal direction is 0? Everybody? Yeah. So can I say change in the velocity in x direction will be 0? Are you guys able to digest this? What is the question? Read the question in front of you. What is the question? You can't even read 2 lines of what? Guys, the force acting on the ball in the horizontal direction is 0. There is no force acting. If there is no force acting in the horizontal direction, there is no acceleration in the horizontal direction. That means there is no change in the horizontal direction component of the velocity. But in the y direction, the force is not 0. The acceleration in y direction will be non-zero, and the change in y direction of velocity will also be non-zero. That is why people, now I want you people to pay attention to this part. Pay attention to this part. Listen to me very carefully. Let's look at the velocity vectors, horizontal and velocity vector components. Horizontal component of velocity when it is coming to hit the floor, and vertical component of the velocity. Why am I resolving the velocity? Because velocity is a 2D vector. Yes or no, everyone? Velocity is a 2D vector here. So definitely it will have to have 2 components. We will say it is ux and uy. Right, everyone? You see that if we go by the usual I cap and j cap sense of direction, ux ka direction. Can you people tell me the direction of ux? With plus and minus, you'll have to say. What is the direction of ux? It is plus I cap. Plus I cap. Thank you. What is the direction of uy? What is the direction of uy? Minus j cap. Thank you. Now hold on. Everybody hold on. Now this was your initial velocity. Okay? Now this is your final velocity v. This is final velocity x component, final velocity y component. Everybody. What is the direction of vx? What is the direction of vx? I cap. Is it same as that of ux? Is the direction of vx and ux same? I cap. Right, everyone? Does this hold true? Does this hold true? Yes, there is no change in the velocity. Okay, everyone? But look at Vy. Earlier the velocity was minus j cap. Now the velocity is plus j cap. Do you see the change in direction? Do you guys see change in direction? That is why the vertical velocity is definitely changing. Delta Vy is definitely non-zero. सब लोग समझ गए? ये था analytical part of the question. अभी mathematical कुछ भी नहीं किया. We have done nothing in mathematics so far in this question. But we have already understood the question here. Sir, 5 meter per second उसका resultant vector होगा. हाँ, 5 meter per second कोई resolve किया ना विहान? 5 meter per second कोई तो resolve किया है ux और uy में. Okay, चलो guys. Now we'll find out. Now switching off the chart so that you guys pay attention to the screen. This is initial velocity. This is its initial component in x direction. This is initial component in y direction. So everyone, I'm writing the initial momentum vector, which is going to be m u vector. And what is u vector? U vector is ux I cap minus uy j cap. So why are you writing minus here? Because we already know it is on negative direction, the y component. You guys only were shouting about it because we all understand this. Okay guys, the sign convention. This is x, this is y. Okay guys. Now, everyone, I have given the values of sine, cos, 53 degree and everything that we need here. So we'll take it from here on this slide. Everyone, pay attention. I'm going to remove this part very soon. If required, if space is required, I might remove this sine and cos apart from here. Any which way. So everyone, how will I write ux? This angle is 53 degree. So definitely this angle is also 53 degree. So I can say that ux is going to be u cos 53 degree I cap. ठीक है, सभी लोगों को समझ में आ रहा है? X component is going to be cos 53 degree component minus uy is going to be, in fact, u का value is also given 5. So I'll write it as 5 cos 53 degree I cap and uy will be 5 sin 53 degree j cap. ठीक है, everyone? Repeating once again, if you have a vector whose magnitude is 5 and it is making an angle of 53 degree, the x component will be 5 cos 53 degree, the y component will be 5 sin 53 degree. But in this our case, the vector is not in first quadrant, the vector is in fourth quadrant. That is why the y component is coming out to be negative. So removing this part, we have this already. I'm not simplifying this part. Do we have the mass of the ball already given to us? 1 kg. Very good. The mass of the ball is also given. Loving it. So P initial vector done. Not simplifying it yet. Now I will write the final momentum, Vp final. Angle is 53 degree. I do not know how much is the velocity. Let's call it V. But I'm sure this angle is 37 degree. This is Vx. And this is Vy. Okay, guys. So mass into final velocity vector, and this is going to be, everyone, m Vx I cap positive direction and plus Vy j cap, because Vy is also on positive y direction. Now everybody, mass is 1 V cos 37 degree I cap plus V sin 37 degree j cap. Purely vector so far. Nothing else has happened. Only vectors. I've only written two-dimensional vector form. Resolution of a 2D vector has been done. Everybody, now we know that when this is happening, okay, we know from here the velocity in x direction is unchanged. Okay, so we know that the change in velocity in x direction and change in momentum in x direction is basically 0. Therefore, we can say that P initial or Px momentum initial and Px momentum final will be equal to 0. Means what? Whatever was the momentum here is also the momentum here in x direction. There is no change happening in the velocity or momentum in the x direction, everybody. So what will I do? I will equate the x component of the momentums. These are the x components of the momentum, everyone. I hope you guys are following me. So initial momentum is 1 into 5 cos 53 degree. This should be equal to 1 into V cos 37 degree. Okay, everyone. I hope you guys are able to understand. This is Px, this is also Px. This is Py, this is also Py. Or you can say this is Py dash, Px dash. Okay, so this is initial, this is final, equated. Now what happens? I get the value of V from here. So 5 cos 53 degree ka value. What is cos 53 degree, guys? It is 3 by 5. इसलिए मैंने बोला, just listen to what I'm doing. This is not challenging at all. You just have to follow step one by one. Okay, this is mass already is 1. V, I do not know how much it is. That's what we are finding. And cos 37 degree ka value is 4 by 5. 5 and 5 cancels. V comes out to be 15 by 4 meters per second. So velocity definitely changed in terms of magnitude also. Because earlier it was 5, now it has become less than 5. It has become close to 4, just less than 4 actually. Now people, we want to find out overall impulse. So we see that there is no change in the impulse in the x direction, there is no change in the momentum. Now I will calculate the change in momentum in y direction. And that is going to be the Py in final case, the final y component momentum minus the initial y component of momentum. Okay, guys? So pay attention to this momentum part, everyone. The final y component momentum is V sin 37 degree. V sin 37 degree, everyone. So I'm writing 1 into V sin 37 degree. J cap, I need not write because now I'm dealing with y axis only. Subtract, what am I going to subtract here? I'm going to subtract minus 5 sin 53 degree. Minus has to be taken into account because of the direction. We just now solved the questions where ball was first going here, then it was coming here. So already V sin 37 degree has been written. Now I will subtract this part. I'm going to subtract minus 5 sin 53 degree. Minus 5 sin 53 degree. It is all mathematics, everybody. What is V value? We got the value of V as 15 by 4 sin 37 degree. All of you will need this once again. Okay, so sin 37 degree is 3 by 5. Minus minus becomes plus. Minus minus became plus. 5 sin 53 degree. Okay, sin 53 degree is 4 by 5. So guys, what do you see? 5 is cancelling this 3 times. 5 and 5 got cancelled. What do I have? I have 9 by 4 plus 4, which is 9 plus 16 by 4, or simply 25 by 4. That means what? 6.25 Newton second. Okay, this is delta Py. Delta Px was how much? It was 0. So overall change in momentum is change in momentum in x direction plus change in momentum in y direction, and that, my dear friends, is also equal to the overall value of impulse. Right? Impulse is nothing but change in momentum. This value is already 0. So 0 plus 6.25, overall 6.25 Newton second. 6.25 Newton second with plus sign. We got this. Okay, guys, everyone. I know you might have certain doubts. Keep them noted. Don't ask me as of now. Keep them noted. Keep them noted. You can ask me if you have still doubts in this. You can ask me at the end of the class. Okay, everyone. It is actually not difficult if you understood this. Okay. Actually, if you will see this question 3 months from now, when you guys will look at this question 3 months from now, you will actually say it is a very simple question. It is lengthy, no doubt. It is lengthy, but definitely you will find it easy. Okay. Okay, everyone. So please show last slide of the solution. This is the last slide of the solution. Shivam Sharma. Actually, it is solvable in 1 second or 1 minute. It is solvable in 1 minute. Okay, not exactly 1 minute, 2 minutes. You can solve it. Okay, everybody, should we go to quizzes now? Now quiz is coming on the way for all of you. Ready? Everyone? Okay. Question for all of you guys, switching off. Okay. A 6-gram bullet is fired at a velocity of 350 meters per second. Okay, 6-gram bullet is fired with a velocity of 350 meters per second in a container of ballistic gelatin that stops the bullet in 1.8 millisecond. Basically, you have fired a bullet and in front of it there is a stopper. Stopper means there is a surface in which the bullet is penetrating inside, and when it penetrates, it takes 1.8 milliseconds for that surface to stop the bullet. Okay, to stop the bullet. What is the average force that stops the bullet? Means what is the average force which is acting on your bullet? You have to find out the rate of change of its momentum. Giving you guys 90 seconds, and the time starts in 3, 2, and 1. Remember, when the bullet stops, its final velocity is 0. When the bullet stops, its final velocity becomes 0. Remember that. Okay, everyone? 20 seconds more. You have the mass of the bullet, you have the initial and final velocity of the bullet, you have the time taken by the bullet to stop. Seconds more. You have the mass of the bullet, you have the initial and final velocity of the bullet, you have the time taken by the bullet to stop. Just calculations. Come on, come on, come on, everyone. Not very impressed. Why you could not solve it? The force is going to be m into v final minus v initial upon change in time. Guys, which of the option I can certainly eliminate? Which of these options I can certainly eliminate? I can eliminate A and C. Why? Because final velocity is 0. Final velocity is 0, so definitely answer is going to be negative. Right? So ये figure out कर लेना चाहिए था. So mass is 6 into 10 to the power minus 3 grams is not SI unit. Final velocity is 0. Initial velocity is 350. Time taken is 1.8 into 10 to the power minus 3 seconds. Okay? Yeah. So what do I have is 6 by 18 into 60 by 18. 10 to the power minus 3, 10 to the power minus 3 gone, and 350. So what do I have here is 10. This is 3. So this comes out to be 1.2. So I can write it as 3.5 by 3 into 10 to the power 2. Am I right? Answer is 1.6 something. How? Answer is not 1.6 something. 35 by 3 is definitely 1.2 something. 1.16 can be brought very close. Correct? So when we simplify this value, it will come out to be 1.2 into 10 to the power minus 3. Yeah, 1.16. Can we not write it as 1.2? How silly that doubt is in itself. Okay, guys. Will the force be called impulsive? Will the force be called impulsive? Yes. Why? Because it is acting for a very short duration of time, and it is able to stop this fast moving bullet. Okay, everyone? And that's why the correct answer came out to be minus 1.2 into 10 to the power 3. Okay? Okay, everyone? 10 to the power 3 तो है मेरे भाई. What happened? चलें आगे? Okay. Next question, guys. Pay attention. It says that figure shows an estimated force time graph for a basketball struck by a bat. Sorry, baseball struck by a bat, or you can say a cricket ball struck by a bat. So what does it show? That for 1 second there is no force acting on the ball. At t equal to 1, the force acts, it increases suddenly, rises to value b, and then the force reduces suddenly and becomes 0. This entire thing happens for this small duration of time, that is 1.5 seconds. 2.5 minus 1. 2.5 minus 1. That is 1.5 seconds for which the force is acting, which is a decently short duration of time. Question says, or whatever be the duration of time for that matter, doesn't matter. For this curve, we have to determine the average force exerted on the ball. You can see that the force is not constant. So we have to find out the average value of the force which is acting on the ball for this duration of 1.5 seconds. How will you always calculate the average force? Is basically the change in momentum upon the change in time. That gives you the average value. Total change in momentum upon total change in time is what you will find out. So how do I calculate this? So can I say that if force and time graph is given, if I find out the area of this graph, what do I get? If I find out the area of this graph, what do I get? I get the impulse or I get the change in momentum, both. Okay, impulse is the value that I get, or the change in momentum is what I get. So if I get the value of change in momentum, I will divide it by the total time taken. I'll be able to calculate the total force. समझ में आ गया? क्या करेंगे? Do you guys understand what we are going to do? We are going to first find out the area of the graph, then we are going to divide it by the total time taken. Okay, do you guys want to try this? Everyone, try करना है? ठीक है, start solving. Giving you people 90 seconds, and the time starts in 3, 2, and 1. One minute is left. Twenty seconds remaining. And last 5 seconds, everybody. Time's up. Let's see. area half into base, which is 3 by 2, 1.5 is 3 by 2, into height, which is 1800, 18,000. I'm not even going to simplify this. Like, trapezium, the triangle hai yaar. It's a triangle. Why trapezium? Does it look like a trapezium? It looks like a triangle to me. It's a triangle. And how do I calculate the force? Change in momentum upon change in time. So change in momentum is 1 by 2 into 3 by 2 into 18,000 and divided by the change in time, that is 3 by 2. So 3 by 2 and 3 by 2 gets cancelled. Very, very, very simply, answer comes out to be 9,000. Got it, everyone? Without even doing any calculation. Without even doing any calculation, honestly. No, these questions don't come in J. The one that come in J, you will see in some time. Okay. Next question, and you have to find out the value of impulse, force, and time graph is given to you, giving you 60 seconds. Directly solve. 3, 2, and 1. Sir, I was a fool to half the time taken. Lol. Okay, no problem. Sometimes we make silly mistakes. That's how we learn, but do not repeat the mistakes. Easiest of the question today. One of the easiest, in fact. Just find the area. Somebody was talking about the area of trapezium. Here is your big chance to apply the formula. Okay. Apply the formula. Be happy. Don't blame me now. इतना easy question दिया तुम नहीं करोगे तो what will I do? हाँ? और अगर trapezium formula भूल भी गए तो दो triangle और एक rectangle है ना? Half into sum of parallel sides. This is 3. This is 1. Right? So 1 plus 3 into 10 to the power minus 3. Why 10 to the power minus 3? Why 10 to the power minus 3? Because it is milliseconds. Okay, and the gap between them is 500. So this is 4 by 2. So 2 cancels it 2 times. 2 into 500 is 1000 only. कितना टाइम ले रहा हूँ मैं इसको सॉल्व करने के लिए? It is actually supposed to be found without even lifting the pen. Okay. Theory of trapezium पता है? वो फॉर्मूला लगाया. Okay. दो पैरेलल लाइंस के बीच का गैप 500 है. नेक्स्ट वन एवरीबॉडी. बहुत तुम लोगों को क्यूरियोसिटी थी ना जेई में कैसे क्वेश्चंस आते हैं. इन फ्रंट ऑफ ऑल ऑफ यू. Switching off the chat in front of you guys. A particle. Before I even read the question, if you have any doubt in the previous question or previous question or previous to previous question, just hold on. This is the second last question. Okay, everyone. Sir, when will you teach the graphs like hyperbola and parabola? Class teacher, tell this to Nayan Sharma. This is physics class, not mathematics. I don't teach parabola or hyperbola here in physics. This will be taught to you in mathematics. Okay, so I will not be teaching you graphs which are parabolic or hyperbolic. I will be using the knowledge which you will be getting in the class of mathematics. Okay. So for people who have doubts in the previous question, please note them down. This is our second last question. After this, we'll open to the doubts only. So question says it's a JEE 2019 question. A particle of mass m is moving in a straight line with momentum p, starting at a time t equal to 0. A variable force is acting on the body. Okay, so it is acting in the same direction as that of the momentum, and it acts for a time duration from t equal to 0 to t equal to capital T. The capital T has not been given a numerical value, so it's a variable time given a value as capital T. Okay, so this momentum changes from initial momentum t equal to 0, where the momentum is p, to final momentum, that is 3p. So question is asking you to find out the value of t. Okay, so the hint has already been given in the top for all of you guys to look at, giving you people 90 seconds, and the time starts in 3, 2, and 1. Come on, guys. All I can tell you is you may require the process of integration here. You may require the process of integration. Half time is gone, 45 seconds remaining, everyone. Okay. Last 10 seconds now, come on. Let's see how well you are able to apply integration applications. So guys, we have been given force as kT. Listen to me now. The force is given to you as kT, which you can say is rate of change of linear momentum. I can write rate of change of linear momentum, dp, I can write as kt, taking this dt here, it looks like this. So I can integrate this, and I can integrate the right hand side as well. The time is going from 0 to capital T, momentum is going from p to 3p. The limit has been given. Momentum is changing from p to 3p. Okay, so integration of dp will be p, you will put the limits from p to 3p. K remains as it is. Integration of t will be t square by 2, you will put the limit as 0 to capital T. So here 3p minus p will be equal to k by 2 into t square. Question is asking us the value of t. Okay, so this is 2p equal to k by 2 into t square, or t square will be equal to 4p by k. So t comes out to be 2 under root of p by k. 2 under root of p by k. That's your answer. 2 under root of p by k. Have a look. We are on the slide where question is being solved. आया समझ में? This is one of the easiest integration questions that you can expect in JEE. ठीक है? Cool. चलो, let's go ahead. We did this. Now, people, let me explain the question to all of you. This is JEE 2010. The figure shows the position time graph. This is position and time graph. The slope of position time graph is velocity. Let me tell you that. Slope of this graph will be giving you the velocity. Okay. So question has given us the position time graph and the mass of the body is 0.4 kgs. Question is asking you what is the magnitude of each impulse. First of all, where exactly the impulse is acting, where exactly the impulse is there on the body. So look at this graph which I have drawn, only the portion 0AB or OAB. I have drawn this graph here. So everyone pay attention to this, then only you'll be able to solve it maybe. From O to A, if you try to find the slope of the graph, switching on the chart, from O to A, can I say that the slope is positive, everyone? And it is positive velocity, right everybody? And constant also. So O to A velocity is positive and constant. Positive means body is going in this direction and with positive constant velocity. From A to B, the slope is negative and constant. Negative and constant. That means from A to B, this is the direction of velocity and constant. Where do you think the change in direction happened? At which point the change in direction happened? At which point the change in direction happened on the graph? At A. And that happened within this time. Fraction of seconds when that happened. So what is the impact point? That is where the force acted for fraction of seconds on the body. Are you guys getting my point? Right, everyone? Yes, O to A is initial velocity, A to B is final velocity. Can we calculate the slope value? That is what you have to find out. B initial and B final you will have to find out. So you want to find out the impulse, which is going to be change in momentum. Now I'm going to give you guys 90 seconds and the time starts in 3, 2, and 1. Only magnitude of impulse is being asked. By the way, impulse point is not only A, there are multiple impulse points. Ball is basically being dropped, it hits the ground, goes up, hits the ground, goes up, hits the ground, goes up. That's what is happening. So impact is happening on it multiple times. Or it could be any other situation. This could be like somebody hitting the ball again and again and again, like that. It could be a table tennis kind of situation. A ball is there and it is moving between table tennis racket and going down, hitting the floor. O to A initial velocity, A to B final velocity. Find out the change in velocity multiplied by the mass. You get the value of change in momentum. Come on, everyone. And the time is up. Very good, very good. Kya baat hai? What a difficult question you guys can do. Easy questions you are not able to do. Huh? So B initial. What is the slope of this graph? Can you people tell me the slope? Tan theta value. Tan theta value. Can I say it is 2 by 2? It is 2 by 2. Opposite upon adjacent. Positive hai. So plus 1. Which I ask you people to write all the time. V final is again the same slope but negative value. So minus 1. Right? So what is the change in velocity? V final minus V initial. And I only want the magnitude of it. I only want the magnitude because all my options are positive. So can I say that it is minus 1, that too in modulus? So how much is the value? Everyone? Can I say it's going to be 2 meters per second directly? So what is the impulse value? Change in momentum. Mass is given to us as 4 by 10.4 multiplied by 2 comes out to be 0.8 Newton seconds. Sabko samajh mein aa gaya? Easy it is now. Only the understanding has to be clear. Okay? Very good, guys. So that is our answer, and this is the end of the discussion as well. For the first time, I guess. Yes. So it was a power pack session today. Leaderboard for all of you. Second time, kya? No, the chapter is still 3 more sessions to go, I guess. 2 more sessions. Congratulations, all of you. Oh, we did so many questions. I didn't know we did so many questions. Okay, Archana, you don't have to spam. Okay, so congratulations, all of you. And the rocket coming up. Yes, a great job. Slope is tan theta. So why does things doesn't break if we fall on the cushion? If they fall on the cushion, because the time of impact is very high. It is increased. That's why. So momentum change takes time. So it doesn't apply much of force on the body. So it doesn't break. That is why. Okay. Theta is 45 degrees. Yes. That's why the value came out to be 1. Theta was 45 degrees. That's why the value came out to be 1. Okay. Now people, those who are done with their doubts and everything, they can leave the class as well. And आज ज़्यादा extend नहीं करेंगे. I'll not speak anything which is not academic today because I have to also get ready for the meeting. And class teachers, you once done with the doubt, you can also leave the class. Okay. So explain the last step of the last question. This we are talking about. Okay, last step of the last question. Change in momentum is mass into change in velocity. Mass of the body is 0.4 kg. Change in velocity is 2. So this comes out to be 0.8 Newton second. Okay. Yeah. Sir, I'm finding slope में difficulty. Yes, Rajkumar. Yes, sir. Tan theta निकालो इस triangle के लिए. Tan theta कैसे निकालूंगा? Opposite upon adjacent, right? तो ये theta जो है इसके लिए tan theta निकालना है called slope basically. Theta पता नहीं होगा तो sides पता होंगी. जैसे यहाँ sides पता है, theta नहीं पता है हमें. इसीलिए तो tan theta का value निकाला opposite upon adjacent. हाफ ही triangle लेना है. हाफ ही triangle लेना है. Full triangle नहीं लेना है. Slope find out करने के लिए. डिफरेंस लगाने के लिए उसको राइट एंगल ट्रायंगल बनाना ही पड़ेगा, इसलिए tan थीटा डिफाइन नहीं कर पाओगे. सर एक्सटी ग्राफ में वेलोसिटी स्लोप से निकलता है ना? यस, बिल्कुल अमन। सर द क्वेश्चन ऑफ ग्राफ वी गॉट 9000 एज आंसर, व्हाट अबाउट दैट श्वेता? व्हाट अबाउट दैट श्वेता? सर स्लोप इज वेलोसिटी सर, यस, हाँ यस बिल्कुल अमन। कैन यू प्लीज एक्सप्लेन दैट? अच्छा अच्छा, दिस वन we found the area of this graph. Shweta, did you understand the finding area part of it? Vihan, wait a second. Shweta, triangle, you understand the area? Yes. After that, I only divided it by the total time. That is 1.5. That's it. We got the answer as 9,000. Sir, how base is 3 by 2? How much is 2.5 minus 1? Shweta. How much is 2.5 minus 1? Shweta. So can I write 1.5 as 3 by 2 or not? Anywhere. Sorry, how do we write the area of a triangle? Can anyone tell me the formula for area of a triangle? Shweta, what is the area of the triangle? So, how much is the base here? It's 1.5. How much is the height here? 9,000. So half base into height. Sorry, मैंने 9,000 लिख दिया. This is 18,000 only. Height is 18,000. भाई तो पहले अपने सारे डाउट क्लियर कर ले. पहले तो अपने सारे डाउट क्लियर कर ले आज. क्विकली, जल्दी जल्दी डाउट पूछते जाओ. अभी थोड़ी देर पहले तुम्हें समझाया था मैंने या किसी और को समझाया? राजकुमार को समझाया. हाँ बोलो. हाँ बोलो बोलो बोलो. कौन से क्वेश्चन की बात हो रही है? क्या इस क्वेश्चन की बात हो रही है? हाँ, इस क्वेश्चन में क्या नहीं समझा बताओ. अगर एक लाइन ड्रॉ करते हैं तो व्हाट डू यू अंडरस्टैंड बाय द स्लोप ऑफ अ लाइन? व्हाट डू यू अंडरस्टैंड बाय द स्लोप ऑफ अ लाइन इन मैथमेटिक्स, नॉट इन फिजिक्स? एक काम करो, तुम्हारे पास गूगल है, गूगल एक्सेस कर सकते हो. गूगल पे जाके टाइप करो गूगल ट्रांसलेट. गूगल ट्रांसलेट जल्दी, टाइम बहुत कम है. किया? और उसमें इंग्लिश टू हिंदी ट्रांसफर करना. ट्रांसलेट इंग्लिश टू हिंदी. टाइप करो इंग्लिश वाले साइड पे SLOPE, स्लो. क्या है उसका हिंदी का मतलब? डबरा, ढाल. समझ में आता है व्हाट डज ढाल मींस? ढलान समझ में आता है? ढलान क्या होता है? ढलान, अगर एक रोड है और वो अगर ऐसी हो जाए तो ये उसकी ढलान है. तो क्या इस समय जो ढलान है उसके कंपैरिजन में ढलान बढ़ गई? इसे कहते हैं स्लोप ऑफ अ लाइन, स्लोप ऑफ अ ग्राफ. ढलान ऑफ अ ग्राफ इज व्हाट वी कॉल एज द स्लोप ऑफ अ ग्राफ. और उसे मेजर किया जाता है, अब मैं बोल रहा हूँ सुनो, उसे मेजर किया जाता है इस एंगल से. बहुत कॉमन सेंस वाले लैंग्वेज में समझा रहा हूँ. आज समझ में आ गया तो आगे कभी प्रॉब्लम नहीं होगी. ओके. और ये एंगल मेजर करने का सबसे अच्छा तरीका होता है tan थीटा पता लगाना फॉर अ ट्रायंगल, जिसमें हमेशा हाइपोटेन्यूज विल बी द लाइन जिसका हम स्लोप पता लगा रहे होते हैं. आई एम होपिंग ये इक्वेशन देखी होगी तुमने. इसमें जो m होता है दिस टेल्स यू द स्लोप ऑफ द ग्राफ और स्लोप ऑफ द लाइन व्हिच इज बेसिकली tan थीटा. तो tan थीटा पता लगाने के लिए इसकी अपोजिट साइड और उसकी एडजेसेंट साइड, मान लो इसको y बोल दिया, इसको x बोल दिया, तो tan थीटा को बोला जाता है y by x. आया समझ में? तो क्या डिफरेंशिएशन की क्लासेस अटेंड नहीं किया तुमने मेरी? तो फिर आई एम नॉट गोइंग टू टीच द एंटायर कैलकुलस वंस अगेन फॉर दिस मोमेंट यार. प्लीज गो एंड वॉच दैट क्लास वंस अगेन, यू विल अंडरस्टैंड व्हाट स्लोप इज. हाँ, मैं बोल बोल के थक गया. तुम लोग अगर पहले के चैप्टर पढ़ के भूल जाने वाले हो तो फिजिक्स में बिल्कुल गाड़ी आगे बढ़ने वाली नहीं है. ओके. Yes, Adya. What's your question? If we drop a glass plate and same glass plate wrapped in thermocol from same height to a same floor, impulse will be same. Impulsive force will be different. Okay, because impulse is force into time. Where when you are wrapping it in a thermocol, then the impact time will increase, so the force acting on your glass plate will decrease. Hence, it will not break, or it may not break, but the impulse will remain the same. Understood now? Okay. सर किसी क्वेश्चन में हमें सेंटर ऑफ मास डिराइव करना पड़ेगा फॉर पर्टिकुलर पार्टिकल सिस्टम? लगता तो नहीं है, आज तक तो ऐसा हुआ नहीं अंश. सर स्लाइड 49 में ट्राइंगल ऊपर नीचे हुए तो लाइक इफ दे आर नॉट कांस्टेंट एट पी पॉइंट है, तो फिर वो उस पर्टिकुलर टाइम के बारे में बात करेंगे कि कहाँ पे इंपल्स निकालना है. विहान फिर वो बताएंगे कौन से पॉइंट पे इंपल्स कैलकुलेट करना है. जैसे यहाँ तो सब में सेम आएगा, इसलिए उन्होंने डिफाइन नहीं किया कि t = 4 पे निकालो, t = 2 पे निकालो, कहीं भी निकालो सेम आएगा. थैंक यू वंश. सर डू वी डू डबल डिफरेंशिएशन ऑफ स्लोप ओनली टू चेक वेदर इट इज पॉजिटिव और नेगेटिव, राइट? टू चेक दैट क्वांटिटी इज मैक्सिमम और मिनिमम. मोनिश, डबल डिफरेंशिएशन सिर्फ मैक्सिमम मिनिमम चेक करने के लिए किया जाता है. आई लाइक दैट यू आस्क्ड टू गेटिंग अनम्यूटेड. सुधीर टेल मी. हाँ, दोनों के लिए, क्योंकि क्रॉस प्रोडक्ट है ना. v इक्वल टू ओमेगा क्रॉस r है वेक्टर वाइज, और अगर इसका मैग्नीट्यूड लिखोगे तो ओमेगा इंटू r इंटू साइन ऑफ 90 लिखना पड़ेगा, क्योंकि ओमेगा और r के बीच में एंगल 90 होता है हमेशा सर्कुलर मोशन में. ये ओमेगा का डायरेक्शन, ये r का डायरेक्शन, तो इसीलिए मैग्नीट्यूड भी ओमेगा इंटू r आ जाता है. अगर v क्रॉस r करेंगे तो क्या ओमेगा मिलेगा नहीं, ये पूछ रहे हो? तो ये ऐसे तीनों म्यूचुअल परपेंडिकुलर वेक्टर्स हैं. मैं बता देता हूँ कैसे वाले वेक्टर्स हैं. ये ऐसा है, मतलब अगर ये ओमेगा है, ये r है, तो ये v है. एक मिनट, ये ओमेगा, ये r, ये v. तो v क्रॉस r नहीं, r क्रॉस v में ये भी ओमेगा, r क्रॉस v से ओमेगा आएगा. क्या सेंटर ऑफ मास का क्या? जल्दी, सेंटर ऑफ मास से कोई लाइन ड्रॉ करते हैं. ओके. कैन यू टॉक अबाउट एन ऑब्जेक्ट, किसी ऑब्जेक्ट के पॉइंट ऑफ व्यू से बात कर सकते हो इस बारे में? हॉलो कोन, ठीक है, और उसको क्या करें? हाँ, और जहां से सेंटर ऑफ मास की लाइन पास होती है उसके अबाउट उसको एक लाइन पे रख दो या एक थ्रेड पे रख दो। वो बेसिकली वो जो स्टंट करते हैं जो लोग रस्सी पे चलने का, वैसा कुछ है ना। हाँ, वर्टिकली रखना है ना, जैसे रोप है और उस पे वो स्टंटमैन जो सर्कस वगैरह में रोप पे चलते हैं, ऐसा ही कुछ बोलना चाह रहे हो ना तुम? कोई भी ऑब्जेक्ट, कोन या कोई भी ऑब्जेक्ट हो, दैट्स व्हाट यू आर ट्राइंग टू से, राइट? कोन ही रखना है, ठीक है, चलो कोन को रख लो। हाँ हाँ, उसके क्या, कौन ज्वाइन कर रहा है? स्टिक, मैं समझ नहीं पा रहा हूँ तुम क्या कहना चाह रहे हो यार, ये स्टिक है, इसके ऊपर कोन कैसे रखा है? तो ये मैंने वर्टिकली रखा है, तो वर्टिकली अपसाइड डाउन रखना है क्या? कोन ऐसा है और स्टिक ऐसी है। हाँ ओके, बैलेंस होगा, हाँ बिल्कुल होगा, हाँ कहीं भी आए, हाँ उस लाइन पे फॉर श्योर, क्योंकि एक्चुअली अभी कॉन्सेप्ट पढ़ा नहीं हमने, व्हिच वी कॉल एज थॉट। इस समय जितना भी वेट है वो इस बॉडी या स्टिक से पास हो रहा है डायरेक्टली, इसलिए अगर ये जरा सा भी इधर या इधर होता तो ये गिर जाएगा। तो इसके बारे में हम समझ पाएंगे बेहतर जब हम रोटेशन मोशन में कॉन्सेप्ट पढ़ेंगे कॉल्ड एज टॉर्क, तो समझ में आएगा। जैसे एम इनटू एक्स नहीं, वो तो मास मूवमेंट है, उसी को एक्सप्लेन करूंगा, वो पढ़ तो लिया, उसको एक्सप्लेन करूंगा फ्रॉम द कॉन्सेप्ट ऑफ टॉर्क कि क्यों क्यों फॉर्मूला m1x1 इक्वल टू m2x2 होता है अबाउट सेंटर ऑफ मास, ये प्रूव करूंगा मैं तभी, ठीक है? ओके, सर ऑल द बेस्ट टू 2021 जनता फॉर टुमारो। ओके, आई विल कन्वे दिस टुमारो। ओके सर, कैन यू प्लीज गो बैक टू स्लाइड 37 फ्रॉम चेंज इन वेलोसिटी चेंज इन मोमेंटम इक्वल टू 37 37 37 37 37 या 37, तो ये रहा। यहाँ तो कुछ भी ऐसा नहीं है। संकेत, तुम कौन से क्वेश्चन की बात कर रहे हो यार, ये वाला बोल रहे हो क्या? हाँ बताओ क्या करना है इसमें, एक तो माइक्रोफोन नहीं रखते तुम लोग यार। क्विक, विल रैप अप इन नेक्स्ट 5 मिनट्स एवरीबॉडी। आई डिडंट अंडरस्टैंड v इक्वल टू p इक्वल टू 0। पहली बात तो इट इज नॉट v इक्वल टू p इक्वल टू 0, और कहीं भी लिखा नहीं है v इक्वल टू p इक्वल टू 0। जो बॉल है उस पे फोर्स कौन से डायरेक्शन में लग रहा है? जो बॉल है उस पे फोर्स कौन से डायरेक्शन में लग रहा है संकेत, y या x डायरेक्शन? व्हाट जस्ट हैपेंड पीपल, आर यू हियर? किधर गया संकेत? y डायरेक्शन में लगा है, थैंक यू, यस। तो कैन आई से x डायरेक्शन में कोई फोर्स नहीं लगा है संकेत? x डायरेक्शन में कोई फोर्स नहीं लगा है, तो x डायरेक्शन का फोर्स 0 हो गया बॉल पे लगने वाला, तो उसका एक्सेलरेशन भी x डायरेक्शन में 0 हो गया, यस। तो क्या मैं बोल सकता हूं कि चेंज इन वेलोसिटी इन x डायरेक्शन 0 होगी? आई एम नॉट सेइंग vx इज 0, बहुत ध्यान देना इस बात पे, मैंने ये नहीं बोला कि vx डायरेक्शन की वेलोसिटी 0 है, मैंने बोला चेंज इन वेलोसिटी 0 इस डायरेक्शन में। हां, तो अगर चेंज इन वेलोसिटी 0 है तो चेंज इन मोमेंटम भी 0 होगा या नहीं? अगर चेंज इन वेलोसिटी नहीं है तो चेंज इन मोमेंटम भी नहीं है। आया समझ में संकेत? इसीलिए इसीलिए यहाँ पे चेंज इन वेलोसिटी इन x एंड चेंज इन मोमेंटम इन x डायरेक्शन 0, पर y डायरेक्शन में ऐसा नहीं हो रहा है, y डायरेक्शन में नॉन 0 है, और ये हमने प्रूव भी कर दिया कि इट इज नॉट इक्वल टू 0, ठीक है? चलो गाइस, टाइम टू रैप अप टुडे, आज जल्दी रैप अप करेंगे, वैसे जल्दी कुछ रैप अप नहीं किया, जल्दी क्लास खत्म हो गई, इसलिए अपना जो टेक टॉक है वो ज्यादा नहीं चला। रीजन इज बिकॉज़ सरफेस इज फ्रिक्शनलेस, एब्सोल्युटली जैक विद परफेक्टली गॉट इट, बिकॉज़ फ्रिक्शन इज नॉट देयर, दैट्स व्हाई एक्स डायरेक्शन फोर्स इज 0, ठीक? ओके एवरीबॉडी, चलो देन, आई विल सी यू ऑल नेक्स्ट टाइम, इट्स गुड बाय फॉर एज ऑफ नाउ, आई सी यू ऑल, टेक केयर, बाय बाय, साइनिंग ऑफ, हasta la vista, बाय बाय।